Bismillahirrahmanirrahim. Assalamu alaikum. Today we learn about reaction of amines. Amines like ammonia have a non-bonded electron pair on the nitrogen atom. And because of this non-bonded electron pair on the nitrogen atom, amine act as a base or as a nucleophile. So most of the reaction now we are going to consider about amines in them either amine act as a base or as a nucleophile. So let's start aromatic substitution of aryl amine. When amine is attached on the aromatic ring, that is called as a aryl amine. As these amine group when attached on the aromatic ring, they are ring activating group and they prefer the attachment of next electrophile on either ortho or para position, because in this position when electrophile get attached on the aromatic ring is stabilized by the non-bonded electron pair present on the nitrogen atom. So in the presence of amine group on the aromatic ring, the next substituent will be preferably attached on either ortho position or at para position. And electrophilic substitution reaction is shown over here. As we have discussed that these amine groups are strongly ring activating group, and the reactivity of aromatic ring increased in the presence of this amine group, and when they are made to react with the suitable substitutable reagent, all the ortho and para positions get occupied by the electrophile. Like here, aniline is made to react with excess of bromine. No Lewis acid is required for this reaction in the presence of sodium bicarbonate. All the ortho and para position that are available in the starting material will get occupied by the electrophile. Like here, they are occupied by the bromine atom. Another example is shown in which ortho-nitroaniline is made to react with excess of chlorine in the presence of sodium bicarbonate. This also leads to the formation of 4,6-dichloro-2-nitroaniline, as one of the ortho position has already been occupied and only one ortho and para position was available that get readily substituted by the electrophile. So we say that care must be exercised in the reaction with aniline because of its high reactivity. Strong acidic reagents protonate the amino group and leads to the formation of ammonium salt. Now this ammonium salt has positive charge on the nitrogen atom, and this is no more ring activating. This is actually ring deactivating and allows the meta substitution on the ring. Treating the aryl amine with the concentrated HNO3 or sulfuric acid, that are the oxidizing acids, leads to the formation of amine group, and this may burn or explode. So when amine group is attached on the aromatic ring, in order to substitute other electrophile on the aromatic ring, acylation of amine is done, because acylation decreases the basicity and permits the electrophilic substitution reaction. Next reaction is amine reaction with carbonyl compound. We say that primary amine or ammonia react with ketone or aldehyde to form amines, and amines are the analogues of ketone and aldehyde because they have carbon to nitrogen double bond instead of carbon to oxygen or carbonyl group. And the substituted amines are called as a Schiff base. We say that amines are commonly involved as a synthetic intermediate both in biosynthesis and in industrial synthesis. So they are widely prepared by this method. Mechanism: acid catalyzed nucleophilic addition of amine to the carbonyl group. This is the first part of this reaction, in which carbonyl group will protonate, and in the next step the amine will attack on the carbonyl carbon, and deprotonation of the amine leads to the formation of carbonyl amine. Second part of this reaction is acid catalyzed dehydration. And this oxygen will be protonated so that it can be converted into good leaving group. And this oxygen from the carbonyl carbon will leave in the form of water molecule, and further deprotonation of nitrogen will lead to the formation of amine. Now these amines can be further reduced to amine. More examples are shown, like cyclopentanone is made to react with aniline in acidic medium, leads to the formation of cyclopentanone phenylamine, and similarly benzaldehyde reaction with methyl amine leads to the formation of benzaldehyde methylamine. And the reaction with amine derivatives like phenylhydrazine leads to the formation of hydrazone, and this hydrazone is further reduced in the presence of KOH and leads to the formation of alkanes. And similarly, the reaction with the hydroxyl amine leads to the formation of oxime. Alkylation of amine by alkyl halide, as we have discussed this reaction in our previous lecture, that was preparation of amine. Amine react with primary alkyl halide to give alkylated ammonium halide. This reaction proceeds by SN2 mechanism, and this reaction gives best yield with primary alkyl halide. Secondary and tertiary alkyl halide do not undergo this reaction because there the elimination products are the major products over the substitution products, so the good yield is not obtained in that case. Primary amine is reacting with primary halide. This leads to the formation of salt of secondary amine. This salt of secondary amine will deprotonate it and leads to the formation of secondary amine. Now this secondary amine is nucleophilic enough and can react with another molecule of alkyl halide, leads to the formation of salt of tertiary amine. As we know that in this reaction, over alkylation mostly take place. So in order to obtain the good yield, exhaustive alkylation to tetra-alkyl ammonium salt is done, or either the reaction with a large excess of ammonia can lead to the formation of good amount of amines. If enough of alkyl halide is used to alkylate the amine derivative formed and small amount of sodium bicarbonate or dilute NaOH is added to neutralize the HX formed and deprotonate the intermediate alkylated amine. This exhaustive methylation gives tetra-alkyl ammonium salt and different alkylated products are avoided. Like over here, primary amine on reaction with methyl iodide in the presence of sodium bicarbonate leads to the formation of quaternary ammonium salt in good yield. Or reaction with large excess of ammonia also leads to the formation of good yield of a primary amine. Acylation of amine by acid chloride. We say primary and secondary amine react with acid chloride to form amide, and this is a nucleophilic acyl substitution reaction. Mechanism: acid chlorides are reactive because chlorine draws the electron density from the carbonyl group and making it more electrophile, so that nucleophile can easily attack on this carbonyl carbon, and a tetrahedral intermediate is obtained in which chlorine act as a good leaving group and can easily leave from here in the form of chloride ion. In the next step, pyridine or sodium hydroxide will pick up the proton from the nitrogen atom and leads to the formation of amide. And good amide yield is mostly obtained in this reaction. We say that amide is resonance stabilized and do not further undergo acylation reaction. So it is less basic and less nucleophilic than amine, and this less basicity and nucleophilicity of this amide can be used as an advantage in electrophilic aromatic substitution reaction, because now these acyl substituted amide can be treated with acid reagent, dilute acid reagent, or oxidizing agents. So this easily we can substitute any electrophile on the aromatic ring, and at the end we can easily remove this acyl group by simple hydrolysis, that is either acidic hydrolysis or basic hydrolysis. Reaction with sulphonyl chloride. Sulphonyl chlorides are extremely electrophilic, and here we say that this is also a nucleophilic substitution reaction because chloride ion get replaced with the amine. So primary and secondary amine react with sulphonyl chloride and form sulfonamide. And this sulfonamide is actually very important class of the medicine that are called as the sulfur drugs. And we say that this sulfonylamide was found to be effective against streptococcal infection, and sulfonylamide is synthesized by acid analyte, its reaction with chlorosulfonic acid, and chlorosulfonation of acid analyte take place, in which this chloride ion will be replaced with amine, and in the next step the removal of acyl group is done by simple treating it with dilute HCl. Next reaction is Hofmann elimination or leaving of amine group. We say that amine in the form of NH2 group or RNH negatively charged group, not good leaving group because they are basic and they have nucleophilic properties. So first they will be converted into good leaving group by their alkylation. And we say that amino group can be converted into good leaving group by exhaustive methylation, which convert it to a quaternary ammonium salt that can leave as a neutral amine. Exhaustive methylation is usually accomplished using methyl iodide. So amines on reaction with methyl iodide get converted into quaternary ammonium salt, and we say that elimination of this amine group actually take place by E2 mechanism, by molecular elimination reaction. So a good base is required. In order to convert it into good base, we will need to react it with a silver oxide in the presence of water. So this quaternary ammonium salt will get converted into quaternary ammonium hydroxide, and simply by heating of this quaternary ammonium hydroxide leads to the formation of alkene, amine and water. Example is shown: exhaustive methylation of butane to amine, and then further treatment with silver oxide leads to the formation of quaternary ammonium hydroxide. In Hofmann elimination, the hydrogen on the carbon next to that carbon on which amine group is attached will leave and results in the formation of alkenes, water and amine. As you know, here the two products are being formed, one in which the carbon-carbon double bond is least substituted and the one in which it is more substituted. So the decisive product in which the carbon-carbon double bond is more substituted is the least product, and in carbon-carbon double bond is less substituted is the Hofmann product, and that is obtained in this case as a major product. So we say that the Hofmann elimination gives the Hofmann product as a major product, and we say that this reaction can easily be used in order to find out the structure of the complex amine by converting them into the simpler amines, and we can easily predict the direction of reaction. Oxidation of amine. Amine can easily be oxidized even on contact with air during the storage. In order to prevent their oxidation, they are converted into salt. Amine can easily be oxidized by common oxidizing agents like hydrogen peroxide, permanganate, peroxyacid. Like in the example, oxidation of primary amine is shown, in which primary amine on oxidation with the common oxidizing agent of hydroxylamine, and hydroxylamine on further oxidation form nitroso, and nitroso on oxidation form nitro compound. So a mixture of product is obtained in this case. Secondary amines are easily oxidized to hydroxylamine. Tertiary amines are oxidized to amine oxide in good yield. And this structure is similar to the structure of quaternary ammonium hydroxide. This will lead to the formation of alkene and hydroxyl amine, and that is called as a COP elimination. Because of positive charge on the nitrogen atom, the amine oxide may undergo COP elimination, much like the Hofmann elimination. The amine oxide acts as its own base through a cyclic transition state. So a strong base is not required for this reaction. The COP elimination generally gives the same orientation as the Hofmann elimination, resulting in the least substituted alkane. COP elimination occur under the milder condition than Hofmann reaction, and it is particularly useful when a sensitive or reactive alkenes must be synthesized by elimination of an amine. Reaction of amine with nitrous acid. Reaction of amine with nitrous acids are particularly useful for synthesis because nitrous acids are unstable. It can be generated in situ. It means that it is prepared inside the reaction mixture because they readily decompose. And they are prepared by mixing sodium nitrite with cold hydrochloric acid in acidic medium. Nitrous acid get protonated, and loss of water molecule leads to the formation of nitrosonium ion. Reaction with primary amine. Formation of diazonium salts. Primary amine react with nitrous acid via nitrosonium ion to give diazonium cation. Diazonium cation, the procedure is called as a diazotization of an amine. Diazonium salts are most useful product obtained from the reaction of amines with nitrous acid. Mechanism is shown for the diazonium salt formation, and it begins with nucleophilic attack of nitrosonium ion by an amine and leads to the formation of an nitrosoamine. A proton transfer from the nitrogen to the oxygen form hydroxyl group, and second N2N bond is generated. Protonation of hydroxyl group followed by loss of water leads to the formation of diazonium ion. Overall diazotization reaction is shown in which primary amine is made to react with sodium nitrite, and this leads to the formation of diazonium salt in the presence of HCl. Alkyl diazonium salts are unstable and readily decompose to form carbocation and nitrogen gas, so they are not used in the synthesis of other compounds. Reaction with secondary amine leads to the formation of an nitrosoamine. Secondary amine react with nitrosonium ion to form secondary N-nitrosoamine, and they are sometimes called as a nitrosoamine. And secondary nitrosoamines are stable and they are separated from the reaction mixture as an oily liquid. Reaction of arene diazonium salt. Arene diazonium salts are relatively stable in aqueous solution at 0 to 10 degrees centigrade, but at the temperature above this temperature leads to the decomposition of arene diazonium salts as well. Arene diazonium salts are formed by diazotizing a primary aromatic amine, and this diazotization is done in the presence of sodium nitrite and in the presence of HCl. And now we say that this diazonium group can be replaced with many other groups, and these arene diazonium salts are used in the synthesis of many other aromatic compounds from them. Here some examples are shown which will be discussed later one by one. Replacement of diazonium group by hydroxyl. This is called as a hydrolysis, and we say that acidic hydrolysis of diazonium salts leads to the formation of phenol. Diazo group will be leave from here in the form of nitrogen gas, and hydroxy group will get attached on the aromatic ring and phenol is obtained. Example is shown in which this amine group will be first converted into diazo group, and then this diazo group on treatment with sulfuric acid and water will get converted into hydroxy group Replacement of diazonium group by chloride, bromide, and cyanide. This reaction is also called as a Sand-Meyer reaction. Copper salt have greater affinity towards the diazonium salts and they readily react with diazonium salts. Copper chloride, copper bromide, and copper cyanide react with Arene Diazonium salt to give aryl chloride, aryl bromide, or aryl cyanides. The use of cuprous salt to replace the Arene Diazonium group is called as a Sand-Meyer reaction. Sand-Meyer reaction is also an excellent method for attaching another carbon on the benzene ring or aromatic ring. Reactions are shown in which this amino group on reaction with sodium nitrite and HCl will get converted into diazonium group, and this diazonium group on further reaction with copper chloride replaces the chloride ion on the aromatic ring. Similarly, bromination of aromatic ring is shown over here. Replacement of diazonium group by fluorides or iodide. When an Arene diazonium salt is treated with fluoroboric acid, this leads to the formation of diazonium fluoroborate, and this formed inside the reaction mixture as a precipitate, and if this precipitated salt is filtered and then heated, it decomposed to give aryl fluoride. Aryl iodide are formed by treating Arene diazonium salt with potassium iodide. This is one of the best method for making iodobenzene derivative. So aryl diazonium salt on reaction with potassium iodide leads to the formation of aryl iodide. Reduction of diazonium group to hydrogen, deamination of aniline. Hypophosphorus acid react with Arene diazonium salt, replacing the diazonium group with hydrogen, and this is reduction of Arene diazonium. We say that whenever we have to remove this amine group from the aromatic ring, we can simply treat it with the nitrous acid in the presence of HCl and then hypophosphorus acid, and deamination of the aromatic ring will take place. The reaction is sometimes used to remove the amino group that was added to activate the ring. Diazonium salt as a electrophile. Diazo coupling. Diazonium salts are weak electrophile and react with strong activating aromatic ring and results in the formation of azo compound. This process is called as a diazo coupling. As over here, diazonium ion is made to react with aromatic ring that is activated. Either it has NH2 group on it or it has OH group on it, and this will react with a diazonium ion and leads to the formation of an azo compound. As this azo compounds bring two substituted aromatic ring into conjugation with an azo group. So this is a strong chromophore. Chromophore is actually that part of molecule which is responsible for color producing. Therefore, most azo compounds are strongly colored and they make excellent dyes known as azo dyes. Many common azo dyes are made by diazo coupling. Like over here, the reaction is shown in which diazonium salt is reacting with the activated aromatic ring, and this leads to the formation of methyl orange, that is an indicator, and it has its own characteristic color, that is orange. So that's all about the reaction of amines. Thank you so much, students.